All right, so we will do a few examples about long polynomial division. Let us start with the first example. Let us assume that we are dividing x cubed minus x squared plus 3x minus 10 by x minus 2, and we want to know what the answer is, and the method that we are following is long polynomial division. So just like regular division, we're dividing x cubed minus x squared plus 3x minus 10 by x minus 2. So now you want to write something here that when you multiply it, when you multiply this by x minus 2 and you want to write the result here, it needs to start with x cubed. You want it to start with the same thing as here, and this is something that we're going to see repeated with every step. So what do you multiply by x minus 2? What do you multiply by x minus 2 so that it starts by x cubed regardless of how it continues? We don't care about how it continues. Obviously the answer here is x squared. And now we do the multiplication. X squared times x minus 2 is x cubed minus 2x squared. And the operation that we're doing now is subtraction. X cubed minus x cubed is 0. Minus x squared minus 2x squared. This is the same as plus x squared. Now in the second step, we're going to see how instead of simply subtracting, we can do something a little bit different. And now these go down, or you can take only one of them down. It doesn't matter for this step. Now you have to think, what do I write here so that when I multiply it by x minus 2, it has to start with x squared. Why x squared? Because you want to get the exact same term that is written here, because you want it to cancel out. So let's start thinking, what do I multiply by x minus 2 to give me x squared? Obviously the answer is x and plus x. Now we do the multiplication. X multiplied by x minus 2 is x squared minus 2x, and the operation that you're carrying out now is subtraction. Now this is what I would like to explain a little bit. Instead of subtracting, instead of carrying out this subtraction, you can do addition as long as you invert the signs of these terms. And let me explain to you why. When I'm doing minus x squared minus 2x, this is the same as doing x squared plus 2x. So you can change your subtraction to addition as long as you invert these signs. So now let's do this. 3x plus 2x is 5x minus 10. Let's do the same thing here. What do I multiply by x minus 2 so that it starts with exactly 5x? Again, regardless of how it continues. I don't care how it continues. So obviously the answer is plus 5. 5 times x minus 2 is 5x minus 10. We're supposed to do subtraction. Instead of subtracting, we can add as long as we invert these signs, and the remainder would be 0. This means that the result of this division is x squared plus x plus 5. Let us do two more examples about long polynomial division. Let us first of all do this one. X squared plus 3x plus 2 divided by x plus 2. Remember, what you write here and you multiply by x plus 2, you want it to start with x squared. You want it to start with the exact same term as here. So what do you multiply by x plus 2? So that it starts by x squared. Obviously, it is x. Now you do the multiplication. X times x plus 2 is x squared plus 2x. The operation that you carry out now is subtraction. Instead of subtracting, you can add as long as you reverse these signs. So this is 3x minus 2xx plus 2. Now you want to write something here so that when you multiply it by x plus 2, it starts with x. Always go for the exact same first term. The answer is 1. 1 multiplied by x plus 2. You carry out subtraction. Instead of subtracting, you can add as long as you reverse these signs, and the remainder would be 0. This means that when you divide x squared plus 3x plus 2 by x plus 2, the answer would be x plus 1. Let us do one more example. Let us assume that we're dividing x squared minus 4 by x plus 2. Now, of course, this might be easy because it's a remarkable identity, but anyway, let us try to follow the long polynomial division method just so that we can learn it a little bit more. So you want to write something here. When you multiply it by x plus 2, it needs to start with exactly x squared because you want to get rid of the first term. So what do you multiply by x plus 2 to give you x squared? The answer is x. You carry out your multiplication. This is x squared plus 2x because x multiplied by x plus 2 is x squared plus 2x. So you're doing just regular multiplication. Now you want to subtract, and as we said, instead of subtracting, you can add as long as you invert or reverse these signs. So this is x squared minus x squared. This is 0x squared, and watch out that here you do not have the term x, so we assume that it's 0. 0x minus 2x is minus 2x, and you bring this minus 4 down. Now you want to repeat the same thing. You want to write something here so that when you multiply it by x plus 2, it starts with minus 2x. Why minus 2x? Because as we said, you're trying to go for the same first term that is here. So you ask yourself, what do I multiply by x plus 2 so that it starts with minus 2x regardless of how it continues? I don't care how it continues. And obviously the answer is minus 2. Minus 2 multiplied by x plus 2 would give minus 2x minus 4. The operation that you carry out now is subtraction. Instead of subtracting, you can add if you change, invert, reverse these signs. Minus 2x plus 2x is 0x. Minus 4 plus 4 is 0. And that's it. You have a remainder of 0, which means that x squared minus 4 divided by x plus 2 is actually x minus 2. Now, I repeat that this we already know it because we know the remarkable identity a squared minus b squared is a minus b into a plus b, and x squared minus 4 is the difference of two squares, which is x squared minus 2 squared. So this is x minus 2 into x plus 2. So we already know this, but as we said, we tried to do it this way just for us to learn or practice on long polynomial division.